today you're gonna learn what an inverse is and be able to find the inverse of a relation. And I wanna first start off by asking you, do you guys know what an inverse is? Opposite. Let's write that down, opposite. What does opposite mean?
Not the same.
Not the same.
Total different.
Total different. Let's talk about numbers since we're in math class. What would be the opposite of the number 2? 4?
-2.
-2. What's the opposite of -10?
10.
10. What's the opposite of 1/2?
Negative.
-1/2. So, the word opposite, you are absolutely correct. Opposite means you change the sign. Opposite, you change the sign. So, I'm gonna tell you inverse is not opposite. It's not what that is. Inverse does not mean opposite. Opposite means change the sign, you're correct. How about reciprocal? What does the word reciprocal mean with numbers? So if I give you the number 2, what's the reciprocal of 2? Anyone? What do you do with the number 2? When you, how about 2/3? What's the reciprocal of 2/3?
2.
Oh,
So was mine.
see, you do know. So what's the reciprocal of 2? 1/2. Reciprocal, you flip the numerator and the denominator. So what's opposite? Change the sign. Reciprocal, you flip. And now inverse. Inverse is not opposite, it's not reciprocal, it is, you're gonna switch roles. So your x becomes your y and your y becomes your x.
Oh, okay, that makes sense.
That's what inverse is. Inverse is when you switch, you're gonna switch the two letters that we commonly use are x and y. Is it always gonna be x and y? No, it could
No.
be t and s and t, it can be a and b. But let's just stick with x and y. So inverse is when you switch roles. The x becomes the y becomes the x. So in other words, the domain becomes the range and the range becomes the domain. That's all that inverse is. Now can you keep those 3 things straight?
Yeah.
Opposite, switch the signs. Reciprocal, you flip it. Numerator becomes a denominator. Denominator becomes a numerator. And then inverse, you switch x and y. So let's start off with some basic stuff. What is this called? This is a relation. A relation is a set of ordered pairs. Do you guys remember the word domain and what does it mean? The domain is all of the what values? All of the x values. The domain is all of the x values. So if I asked you, what is the domain of this relation? Can you correctly state the domain?
2.
I heard 2 and then I heard 4. The person that said 2 is starting off correct.
2, 4, 6,
6,
8.
2, 4, 6,
Physical order.
8, 12. So what do? We put them in order from least to greatest. Now what is the range? What?
Very good certified over.
What's the range?
3 times 7.
The range is the y values.
3, 5, 7.
3, 5, 7.
20.
Should I write 7 twice?
No.
So all that inverse is gonna be is switching your x and y around. So your range will become your domain. So if I wanted the inverse of this will be the domain, and that'll be the range. So let's do an example here. You have another relation. Let's see if you can state this relation is called R. Can you give me the domain correctly of this relation?
0,
I heard 0, 1, 2.
0, 2, 4, 8.
And what's the range?
1,
Now, if I asked you to find the inverse of this relation, how are we gonna write it?
1,
3,
2,
2,
and then 0, 2,
2,
8, 2, 4, 8.
Easy?
Yeah.
Okay. Now, check out this next example, problem 1, finding the inverse of a relation. So here's a relation, this is called T. Can you get each point, each ordered pair has an inverse. So the inverse of 0, -5 is -5, 0. What's the inverse of 1, -4?
-4, 1.
How about the next one?
-3, 2. And then -3, -3, 3.
So I want you to graph relation T and the inverse. How do you graph this relation? Well, just plot these points, 0, -5, 1, -4, 2, -3, and 3, -3. And I want you to graph the inverse over here. -5, 0, -4, 1, -3, 2, and -3, 3. Now, what's funny is this relation, the relation stated as, this is T, is a function, right? Do you remember what a function is? There's two ways to determine whether a relation is a function. You can look at the what values.
X.
Do any of them repeat? No. How about, can you draw a vertical line through the graph? Yes. Is this a function?
Yes.
Yes. This is a function. There's two ways that we can tell whether a relation is a function. For every x, there's only one y. We can look at the x values, if any repeat, then it's not a function, but these are good. And same with the graph. If you could draw a vertical line through it. Now check this one out.
That one's not.
Is just because a relation is a function, doesn't necessarily mean that its inverse
No, it's not.
relation will be this is the inverse relation. Is this a function?
No.
Nope. And look at this, if I drew a vertical line through it, it's hitting twice here. So, could you, based on looking at just your relation, not the inverse, this is the relation, this is the inverse, can you tell me a way to predict whether or not the inverse will be a function?
Look at the y value.
Very good, Caitlin. She said, look at the y values. If the y values repeat, then it's not a function. And there you go. Good observation. Now, how will you write the difference
I
between,
can't see the second graph.
you can't see the second graph?
Oh, I thought you were like this or not.
This one is not, this inverse is not a function. Now, how are we going to distinguish between what's a relation and what's an inverse? Well, we use this fancy notation. I just want to talk to you about it. F of x is a function. What's another name for f of x? Y. If you find the inverse of a relation, you're going to use this notation. this means inverse. When you see f to the negative 1 power, that means inverse. So when you see this, that's talking about the inverse of that function. Now, how are you going to find the inverse of a relation if they don't give you a set of ordered pairs? They give you an equation. This is a rule, an equation, y equals 2x plus 8. So what are the directions? What are the steps to find the inverse? Well, what does inverse mean? Inverse means you switch x, your x becomes your y, and your y becomes your x. So what you're going to do is simply, if they give you a relation in an equation form like this, all you do is switch x and y. So see this y value? It's gonna go right here.
You're gonna
And-
plug Y in for X.
Yeah, you're switching roles. That's all you're doing, is switching roles. Now, are we gonna leave it like this? This is the hard part. You have to solve the equation for y. We always want y by itself. So, I'm on problem 2. Does everyone know where I'm at? Problem 2? What do you think 1, 2, and 3 up here are?
What we just did.
They are your homework from problem 1. All you do is graph this and then graph the inverse. Do them both on the same graph. So number 1, you're going to plot these points, and then you're going to plot the inverse. Do it 1, 2, 3, and then we're going to talk about some characteristics of inverse. I'm going to let you see if you can figure it out. But problem 2, if they give you an equation and you want to find the inverse of an equation, all you do is switch x and y around and solve this equation for
Why?
y. How are you going to do that? Now, I'm going to rewrite it here. This says 2y plus 8 equals x, right? How are you going to solve this for y? Subtract 8 and divide by 2. Now, can you write this better? What did I do from here to here? I simplified. You see what I did? I divided this by 2, divided this is just 1/2 x, and 8 over 2 is 4. That's all I did. I simplified. Now, this is the thing. We are naming y as 2x plus 8. Y is not 1/2 x minus 4. How are we going to show someone that this is the inverse of this? This is how you're going to write it. Instead of writing y is equal to 2x plus 8, how could I have written this?
The f minus 1 of
F of x is equal to 2x plus 8. This is what you're going to see. You're going to see this written like that, which is the same thing. Remember, y is f of x. So then how are we going to show that this is the inverse? You're going to write f negative 1 of x equals 1/2 x minus 4. This means that it's the inverse. Now, you can only use this notation if the inverse is a function. How do we know that this is going to be a function? Well, if we were to graph this, this passes what we call a horizontal line test. And remember the vertical line test? What is the vertical line test? How do you graph y equals 2x plus 8? And we're going to talk about this tomorrow, but I wanted to give you a heads up on this. How do you graph y equals 2x plus 8? You begin at 1, 2, 3, 4, 5, 6, 7, 8, and you go up 2 over 1. Okay? This is the line y equals 2x plus 8. This should be reviewed. How to graph this. Does this pass the horizontal line test, the vertical line test, sorry?
Yeah.
Yes. So, is this a function? Yes, this is a function. But remember what Kaylin said? If any of the y's repeat, then its inverse won't be a function. So in other words, can you draw a horizontal line through this graph instead of a vertical line? If you can draw a horizontal line through the actual function, then and it only hits in one spot, then its inverse will be a function. So because I can draw a horizontal line through this, not a vertical, its inverse will be a function. So instead of the vertical line test, you're going to do the horizontal line test. Everything gets switched with inverses. So because I can predict that this function, its inverse will be a function, I can use this notation. So I'm done. I want you to go up to problem 29. And just be aware, look at this problem number 7. They want you to find the inverse of this. Before you switch x and y around, what do you think you should do with this 3? What do you think you should do with it?
3x plus 3.
Yes.
Distribute
Now, this is the function y equals 3x plus 3. Or you could write f of x equals 3x plus 3. Now, how do you find the inverse of this?
it. Switch y next.
You're going to switch y and x. And you're going to resolve it for y. So you have x, swing 3 over, and then do what? Divide everything by 3. So this is 1/3 x minus, what's another name for 3 over 3? And now you can rename this, instead of writing y, you can write,
F minus 1x.
yeah, because this is the inverse of that. They're not the same, they're both not f of x. This is the f negative 1 of x. This is the inverse. So that's what you're going to do. Are we done?
Yeah.
We're done. So I want everyone right now, I'm giving you a very light assignment because I want you to finish last week's assignment too. Tomorrow we're going to finish this page, the back page.
So we do the graph.
Do the 3 graphs
5 problems.
and then the 6. And turn in
Can I see that package? There was something on this.
what packet?
That one.
This one?
Yeah, I missed it.
Oh my God.
Last time?